Hey friends, today we are going to talk about characteristics of our quadratic functions. The first thing that we're going to talk about is all these characteristics. Really what I'd like for you to do is pause the video here, try to fill in all of these. These should be things that you are familiar with, and then come back after you filled them in and check with what we've got. All right, go ahead and pause it now. All right, so we're going to talk about this real quick. The vertex is an ordered pair. It falls on your axis of symmetry. It's always going to be your max or min. Axis of symmetry, you find that by doing negative b over 2a. Basically, that's where our line of symmetry is. Domain is all your x's. Range is all your y's. We always write those biggest to smallest. If there's an endpoint, you get a bracket. Arrows get parentheses. X and y intercepts, that's where you have to touch or cross the specific axis, and we write that as an ordered pair because they're points on the graph. Your max and min, that's always going to be your highest or lowest y value. Intervals of increase and decrease, these are always x values where your slope is either positive or negative. Your end behavior talks about what your y value is doing as you look to the right or to the left. So if it goes up, your y's are going to approach infinity. If it goes down, your y's are going to approach negative infinity. And when you're finding your average rate of change, that means you're calculating your slope. So between 2 points, if you have a graph, you can just count rise over run from the left point to the right point. If you're going to use an equation and you have 2 points actually given to you, then you can use y2 minus y1 divided by x2 minus x1. All right, so let's actually look at finding all those characteristics on a graph, and we'll walk through this problem together. All right, so we have a graph that's graphed for us already. We're not graphing this one. We just need to identify the vertex. So remember, our vertex should be the lowest or the highest point. Okay, so it's going to be right there. It's the bottom of this graph. So we just need to identify the ordered pair. The ordered pair is going to be -2, +3. Now something that's really cool is your vertex will always fall on the axis of symmetry. So notice that that axis of symmetry is where the symmetry is. So the left and the right hand side are going to be the same. So your axis of symmetry is going to be an x equals, because all the x's on that dotted line are the same, and they're all the x of -2. Okay. The other thing that I'm going to go ahead and label first right now is whether we have a max or a min, because our max and our min really come at our vertex. So our vertex is the lowest point, so here we have a min, and your max and min is always a y value. So this is going to be the y value of what? Well, it's the y value of 3. So hopefully at this point you can notice that this x and this y give us our vertex. So the axis of symmetry and our max or min value comes straight from our vertex. So that's kind of cool. We can use, both of those pieces of information from our vertex. All right, so let's talk about the domain. Our domain is going to be all of our x values. So that means as we look left and then as we look right. Now, what I like to do is when I look at my graph, I like to look at the left side and then I look to the right side. So when I look to the left side, I see that there's an arrow here. That arrow is going up forever and it's going left forever. So as I think through, when I say up forever, well, the values going up are getting bigger and bigger, so they're going to approach infinity. The values that are going to go left forever, well, if we think about our numbers that are going left on a graph, those are going towards the negative, so it's going to approach negative infinity. As we look to the right side of the graph, we see yet another arrow. Well, notice this arrow is going to go up forever, and those values are going to get larger and larger towards infinity. And it's also going right forever, which means that the values to the right on our graph are just getting positive, bigger and bigger, so towards positive infinity. So when I talk about domain, we want to look at the left arrow and then the right arrow. Well, the left arrow tells me we approach negative infinity, and the right arrow tells me we approach positive infinity. So that makes it really easy for me to see that my domain is going to be from negative infinity to positive infinity. Similarly, with the range, these are our y values. That means we need to look down and then up, because we always have to write these smallest and then the biggest. Well, as we look down on this graph, we don't see an arrow going down. Instead, we see that the lowest value that our graph goes is right here at the vertex, at the bottom of the graph, and that is going to be at the y value of 3. Since that is an actual point, it's an endpoint there, we use a bracket, and then we're going to look up to find the highest y value that we're going to approach, and we notice that both sides of the graph are both going up. So this is going to go up forever, so towards positive infinity. All right, x-intercepts and y-intercepts. As we look at the x-intercepts, that means we're looking at the x-axis here. And I'm noticing that this graph does not touch or cross it, so we're going to put none. For our y-intercept, we're looking for where we touch or cross this y-axis here, and we can see right here is where we touch or cross. Now please be careful, remember, intercepts are points on the graph, so we need to write this as an ordered pair. The ordered pair is when x is 0, the y is 11. All right, so now we're going to talk about intervals of increase and decrease. When we talk about intervals of increase and decrease, remember, these have to be x's, and we're talking about slopes. Okay, so when we talk about where it's increase, it's got to be positive slope, and decrease is where we have negative slope. So let's just do the easiest thing first and identify the slopes of this graph. So as we look at the graph, we can see that reading it from left to right, the left side is going to go down, 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 and then the graph starts to go up. So I'm not talking about which way the arrows are going, I'm just talking about as I look from the left of the graph and as I move to the right. So as I move my finger from the left side of the graph towards the right side, I have to go down the graph. So that means the left-hand side of this graph has negative slope. Then once we hit the vertex down here, we change from going down with our finger to going up. So that means the right-hand side of this graph is positive slope. So if you notice, we changed which way our slope went right here at the vertex. So the left side was down and then the right side was up. So that means everything to the left of the axis of symmetry and of our vertex is going to be decreasing slope. So that means everything from this axis of symmetry at -2 and left is decreasing slope. But everything to the right side of that axis of symmetry is a positive slope. So that just tells us that when we talk about this, we need to look at that x-axis. And we need to say, okay, we need to represent everything to the left in the decreasing. So that means from -infinity up until the axis of symmetry at 2. Okay? So that means our interval of decrease is going to be from -infinity to -2. Our interval of increase is going to be where we have the positive slope. So that means from that axis of symmetry and everything bigger. So our axis of symmetry is at 2 and everything bigger will be towards infinity. Okay? Now let's talk about the end behaviors. So remember, as x approaches infinity, that means as we look to the right of the graph, f of x, or my y values, are going to do what? Well, look to the right. As we look to the right of the graph, it's going up forever. So these y values are going to approach infinity. Then as x approaches -infinity, that means we've got to look to the left side of our graph. That's where the x's are getting smaller and smaller. Then our y values, or f of x, is going to approach what? Well, this is really cool with quadratics. Both sides of the graph will always do the same thing. So as we look to the left, it also is approaching infinity. All right, so now the last piece here that we're going to identify is the average rate of change. So our average rate of change is, we're asking from when x is -3 to x is -1. So this means find these two on the graph. That means when x is -3, so come over here to where x is -3, and then go up and find the point on the graph that had the x of -3. Then do the same thing for when x is a -1. That's here. Go up until we find that point. Okay? Now, we have a graph, so we can either count, rise, or run, or we can identify the ordered pairs here and do our slope formula, which is y2 minus y1 over x2 minus x1. Since it's a graph, let's just count. To go from this point here to this point here, we're going to rise 0 and run 2. Well, 0 divided by 2 is 0, so this has a slope of 0. And that's okay, because that means it's a horizontal straight line. All right, so let's look at the next example. Okay, we're going to do this one a little bit quicker. So our vertex here is going to be either the highest or lowest. Since this is opening down, we're going to have a max. It's going to be at the top. So our vertex is at the ordered pair -1, 2. Like we said before, our axis of symmetry and our max or min come from that vertex. So the axis of symmetry is going to be where the x is equal to -1, and we actually have a max this time, and it's at the y value of 2. All right, our domain is x's, our range is y. So let's look at the ends of this graph. This end goes down, numbers going down are getting negative, and it goes left. Numbers going left are also negative. This arrow goes down towards more negative numbers, but it's also moving to the right towards positive numbers. So we're going to look left and then right for the domain. So looking left is towards negative infinity, then looking right is positive infinity. For the range, we're looking at the y, so we're going to look at our arrows down. Well, they both should be going to the same thing, so that's negative infinity. And then as we look up, we're noticing that we don't go any higher than that y value of 2. That's an endpoint, so it gets a bracket. All right, this time we do have x-intercepts. We're going to see we have an x-intercept right here on the x-axis and here, so we need to label them as points. So the one on the left is going to be the ordered pair -2, 0. And then the one on the right side is at the origin 0, 0. We do also have a y-intercept. It's really fun. It's right there. It's that same point, 0, 0. Okay, so then our interval of increase and decrease. Remember we talked about the axis of symmetry is what separates that. Here the left side has positive slope and the right side has negative slope. We know that the left side is positive slope because if you trace it with your finger from left to right, your finger has to go up until you get to the vertex, and then it goes down. So the left side is up, that's positive slope. The right side is down, that's negative slope. That means right here at the axis of symmetry, everything to the left was positive slope, but everything to the right was negative slope. So our interval of increase is going to be the left side of the graph now. So that means everything that's smaller, so negative infinity, up until the axis of symmetry, which is at -1. And then the decreasing side is the right-hand side, so it's everything from the -1 to infinity, which is the positive axis. All right, so remember with end behaviors, both ends should be going in the same direction. So look, which way are both of the ends going? Down. So that means no matter if we look to the left or the right of the graph, our y values are always going to go down. So that means these are both going to go towards negative infinity. And then let's find our average rate of change from -3 to -1. These are x's. Okay, so that's just saying find the point that has a -3x. So find the -3x and drop down and find your point, which is here. Then find where the x is a -1. That's up here at the vertex. This time, I'm just going to count rise over run. So from the left point to the right point, we're going to rise, and then we're going to run. So we rise 1, 2, 3, 4, 5, 6, 7, 8, and then we run 2. So we write 8 over 2, which reduces to a slope of 4. All right, pause this now. Go ahead and work out the next 3 that are already graphed for you and come back and check your answers. All right, here's those next 3 for you. If you need to pause it so you can check your work, then go ahead and pause it. Check and see, make sure you got all those pieces correct. Alright, I'll do the rest of the problems on another video.